Namaste students, welcome to my channel Sumanth tutorial. In this session, I am going to explain you a very basic concept of machine and lever. I hope this video will going to help you a lot. Before that, if you have not subscribed yet, please subscribe my channel and don't forget to like, comment and share. So, the definition of a machine, remember in the Three Idiots, Mr. Chatur Ramalingam said, don't worry, I won't say that definition. So, in the simplest way, a machine is a device which makes our work easier. So, the device which is making our work very easier means which is overcome the load through applying a bit effort. We are applying some effort to overcome the load, that is called as a machine. There are four basic functions of a machine. Let us study which are those four basic functions. The first one, force multiplier. So what is that force multiplier? So it is very simple. By applying a small effort, a maximum work should done. For example, if I want to lift a car, I will use a jack. With small rotation, with a small effort in the rotation of the jack, I can lift the car. So that is an example of a force multiplier. So what is this example? So the example of force multiplier is a jack. That may be the hydraulic or the non-hydraulic. With the small rotation in a jack, I can able to lift the car. So that is what the force multiplier. Second one, speed multiplier. So, where we can observe this speed multiplier? Scissors. If you want to cut a cloth, a small movement in a handle of a scissors, the blades will going to cut a maximum part of the cloth. So that can be considered as speed multiplier. Example is scissors. Clear up? So the third one is changing the direction of effort. We are going to use the pulley. See here, with the rope, we are going to pull the rope down. We are going to pull the rope down. The bucket will come up. Observe, the direction of the effort is downwards. We are pulling it down, but the bucket is coming up. So that is an example where we are going to use it for change in the direction of the effort. So that we are going to use it as pulley. And the last one, that is the fourth one, that is changing and the point of effort. Change in the point of the effort means the best example is the bicycle. Changing in the point of effort means we are putting effort on somewhere and the load or the work is going on the other side. How it is possible? Doing jadoo? No, it is not like that. Very simple. In a bicycle, we are going to pedal in between, but the rear wheel of the vehicle will rotate. How? It has been connected with the gears and a chain with in contact, but where the effort and where the effect is going on. So that we're going to give you the example for changing in the point of the effort. So the example is bicycle or cycle. Clear? So these are the basic 4 application of a machine. Now let us study few of the terms related to the machine. First is the load. So first is the load. What is the load? Load is the opposing force to be overcome by a machine. Next is effort. So what is effort? Effort is the force applied by the machine to overcome the load. So the next is mechanical advantage. It is the ratio of load by effort. This is very important. So what is mechanical advantage of a machine? The mechanical advantage of the machine is the load by effort. Yeah, if the mechanical advantage is greater than 1, it acts as a force multiplier. If it is less than 1, it acts as a speed multiplier. So one more term is there, that is velocity ratio. So what is velocity ratio? The velocity ratio is the ratio of displacement of the effort divided by displacement of the load. This is also important. And one more very important, efficiency, represented by the symbol eta. Efficiency will be equal to work output divided by work input. So this is always represented in terms of percentage and it has no unit. Mechanical advantage, velocity ratio and efficiency will have no unit. There are 2 types of a machine. One is ideal, another one is actual. So what is this ideal machine? A machine which has the efficiency is equal to 100%. A machine which has the efficiency equal to 100% means it is very clear that there is no loss of energy. How much of work I am putting it, that much of I am getting it in back. Nothing but the work output divided by the work input is same. So that is called as the ideal machine. See here, I said an efficiency is 100%, means we will be very happy, right? So how much of effort we are putting, that much of work is we are getting it back. But in practical or in practice or in a reality, it is not possible. Why? Here, few of the things we have neglected it. What are the things that we have neglected? First is the mass of a machine, the parts mass, we have neglected it. We are thinking it is completely weightless. The string, if we are using, it is 100% elastic and there is no friction. Like that we have thought. So what are the things that we have neglected here? That is mass or the weight. Mass or weight. We have neglected. Second one, we thought that the string, if we are using, it is 100% elastic. 100% elastic, and most important, we thought that the machine is frictionless. By considering these concepts, we said that the ideal machine is 100% efficient. But in practice or in reality, that is not possible. That is what we used to learn, that is expectation versus reality. There, while we comes with the concept of reality, we know there is a mass or weight and string, not 100% elastic and friction. So, very clear, this cannot be possible in real. So, what is an actual machine? The actual machine is a machine where the efficiency is always less than 100%. Why it is less than 100%? Because these things are considered. So, for example, if I say a machine is 80% efficient, then the useful work is 80%, the rest of the 20% is lost because of heat energy produced because of the friction and wear and tear in the machinery's arrangement. The part of the machines may corrupt. So that is what the reality. So the basic concept about ideal machine and actual machine. Now let us discuss with the one of the basic machine, that is a lever. So what is a lever? A lever is a rod that can be able to turn with a fixed point. That's all. That is a bar or a rod. So let me draw a lever, a rod with a fixed point called as the fulcrum, one side, load, another side, effort. I said a rod which can able to rotate, with a fixed point, which can turn or rotate with a fixed point. And the distance between fulcrum to load is called as load arm, and the distance between effort to fulcrum is called as effort arm. So what is the mechanical advantage? I said very clearly, mechanical advantage is equal to load divided by effort, or mechanical advantage is equal to effort arm divided by load arm. Very important formula. So the mechanical advantage is equal to effort arm divided by load arm. So there are three conditions for this mechanical advantage. Which are those? Mechanical advantage is equal to 1, mechanical advantage less than 1, or mechanical advantage greater than 1. When it is possible if the effort arm is equal to load arm. If both are same in length, means if the fulcrum is exactly at the center, then mechanical advantage is equal to 1, because effort arm and load arm are the same length. So mechanical advantage is equal to 1. Second condition, mechanical advantage less than 1 if load arm is greater than effort arm. If load arm is bigger, obviously it is less than 1. If it is greater than 1, reverse of it, effort arm greater than load arm. If effort arm is bigger than load arm, then mechanical advantage greater than 1. Now let me explain the 3 kinds of a lever. Based on the position of fulcrum, load and effort, we divide the lever into 3 classes. First is class 1. So what is class 1 lever? If the fulcrum comes in between the effort and load, so that category of a lever is called as class 1 lever. So what is that? So it is a lever, fulcrum, load and effort. If fulcrum comes in between load and effort, that is class 1 lever. If the fulcrum is in between, there are 3 chances. 1, it is exactly at the center, or it is very close to the effort, or it is very close to the load. So I said this class 1 lever in which the fulcrum is it in between. So what happens if it is exactly at the center? Then the mechanical advantage is equal to 1. So what is the example? Seesaw. Seesaw is the best example. Everyone had played in that one. In a seesaw you can observe the rod in which the fulcrum is exactly at the center. Second one example I will take, that is when the mechanical advantage is greater than 1. Condition of mechanical advantage greater than 1, effort arm should be bigger than the load arm. Which is that example? Cutting plier. Observe the cutting plier. The handle length is more than the steel one, right? Which used to hold it as a grip. So if you observe the pliers, their effort arm is more. So that is an example. Now the last case, the mechanical advantage less than 1, scissors. How sir? Handle. The length of the handle is shorter compared to that of a blades. So in that condition, the mechanical advantage less than 1. So very clearly observe this one. The class 1 lever have 3 kinds of mechanical advantage: equals to 1, greater than 1, less than 1. Equals to 1, example seesaw. Greater than 1, example a pair of pliers. So less than 1, example scissors. Clear? Now class 2. So in a class 2 lever, the load comes between fulcrum and the effort. Let me draw a rod. Load, fulcrum, effort. If load comes in between fulcrum and the effort, that will be considered as class 2 lever. The best example is lemon squeezer. Lemon is the load which is to be placed in between the 2 rods to squeeze it, where load comes in between effort and the fulcrum. So now just mark the load arm and the effort arm. I said the distance between fulcrum to load is load arm, and the distance between fulcrum to effort is effort arm. So which is bigger? Effort arm is bigger obviously than the load arm. So the class 2 lever, the mechanical advantage always greater than 1. No other option. In class 1 we got 3 kinds of a mechanical advantage, but that is not going to occur in class 2. In class 2 lever, the mechanical advantage is always greater than 1. Why? The effort arm is always greater than the load arm. So, this class 2 lever always acts as a force multiplier. Mechanical advantage is greater than 1, so it acts as a force multiplier. Now, class 3. If the effort comes in between the load and the fulcrum, that class is called as class 3 lever. Let me draw it. Effort, load, fulcrum. If the effort comes in between the fulcrum and the load. So once again, mark the effort arm and load arm. The distance between effort to the fulcrum is effort arm. Likewise, the distance between load to the fulcrum is load arm. So the ratio here, which is always less than 1. Why? Because load arm is always bigger in class 3 lever. So the mechanical advantage is always less than 1. In class 2 lever, mechanical advantage is greater than 1. In class 3 lever, the mechanical advantage is less than 1. So it is always acts as a speed multiplier. The best example of class 3 lever is sugar tongs or fire tongs. So you might have observed, to pick the sugar we are going to use the sugar tongs. So there you can easily observe the effort is kept in between the fulcrum and the load. So that is the basic concept about your lever.